Hey everyone, and welcome back to the Topic Trick channel. It is great to have you here with us. If you have been following our series, you know we have already covered the basics of performance tuning and the fundamental concepts of database management systems. Today, we are taking a massive leap. We are moving away from the commodity hardware that sits on a desk or in a rack and stepping into the world of the heavy hitters. We are talking about the mainframe. Specifically, we are going to explore IBM DB2 for z/OS. Now, I know what some of you might be thinking. The mainframe? Isn't that dead? Isn't that old technology? Let me stop you right there. If you used a credit card today, checked your bank balance, booked a flight, or filed an insurance claim, you likely interacted with a mainframe, and more specifically with DB2 for z/OS. It is the invisible engine that powers the global economy. It is not dead, it is evolved. By the end of this video, you will understand exactly what DB2 for z/OS is, how it differs from the versions of DB2 you might run on your laptop, how it has evolved over 40 years to support artificial intelligence, and what career paths await you in this ecosystem. So grab a coffee and let's get started. Let's begin with the basics. What exactly is DB2 for z/OS? In our previous video, we defined a DBMS as software that manages data. DB2 for z/OS is IBM's relational database built specifically for the z/OS operating system, which runs on IBM Z mainframe hardware. But calling it just a database is a bit of an understatement. It is a subsystem. In the world of Windows or Linux, you might install a database instance. On the mainframe, we talk about subsystems. DB2 operates as a formal subsystem of the operating system, meaning it is tightly integrated with the hardware supervisor calls and memory management. This tight integration allows it to achieve something called the 5 nines. That is 99.999% availability. We're talking about systems that can stay up and running for years without a reboot, even while you're applying software patches or upgrading hardware. It is designed for what we call systems of record, the absolute source of truth for critical data where failure is simply not an option. Now, you might be confused because you've heard of DB2 running on Windows, or maybe on Linux or AIX. This brings us to the DB2 family. It's important to understand that not all DB2s are created equal. We generally categorize them into 3 buckets. First, there's the one we're discussing today, DB2 for z/OS. This is the big iron. It uses a unique file structure called VSAM, or Virtual Storage Access Method. It relies on a character encoding set called EBCDIC, which is different from the ASCII encoding used by almost every other computer. It is optimized for massive batch processing and high-volume transactions. Second, we have DB2 for LUW, which stands for Linux, Unix, and Windows. This is what you would install on a Dell server or a cloud instance. While it shares the same SQL language as the mainframe version, so a select star works the same way on both, the internal engine is different. For example, DB2 LUW is often used for systems of engagement, like web apps or customer-facing portals. Third, there's DB2 for I. This runs on the IBM I operating system, formerly known as the AS400. This is a unique beast because the database is actually built directly into the operating system kernel. You don't really install DB2 on IBM I, it's just there. It's famous for being incredibly low maintenance, the toaster of databases, because it just works. So to visualize this, think of DB2 LUW as a high-performance sports car, agile, fast, and runs on any paved road. Think of DB2 for I as a self-driving luxury sedan, comfortable and automated. And think of DB2 for z/OS as a freight train. It carries a load 1,000 times heavier than the car. It never stops, and it's built to survive a hurricane. Let's travel back in time for a moment to see how this freight train was built. The history of DB2 is actually the history of the relational database itself. In the early 1970s, IBM researchers invented the relational model, but it wasn't until 1983 that IBM released DB2 version 1 for the MVS operating system, the ancestor of ZOS. In the 80s, with version 1 and version 2, the focus was just on proving that relational databases could work for real business. Before this, everyone used hierarchical databases like IMS. DB2 version 2 was a game changer because it introduced referential integrity, the ability for the database to enforce relationships between tables automatically. By the time we hit the 90s and version 5 and 6, the internet was born. DB2 had to adapt to handle connections from the web, not just green screen terminals. The next major leap came with version 8 in the early 2000s. This was a massive architectural shift because DB2 moved to 64-bit addressing. Before this, DB2 was constrained by memory limits. With 64-bit, the memory limit virtually disappeared, allowing for massive buffer pools and caching, which skyrocketed performance. Fast forward to the modern era. Version 10 introduced temporal tables, allowing you to query data as of a certain point in time without complex coding. Version 12 changed the release model entirely. Instead of waiting 3 years for a new version, IBM moved to continuous delivery. Now, new features are released in function levels every few months, just like updates to your smartphone apps. And currently, we're on version 13. This is the era of AI. Version 13 includes a feature called SQL Data Insights. It uses the AI accelerator built into the latest mainframe chips to run deep learning models directly inside the database. You can now write an SQL query that asks, "Find me customers who are similar to this customer," and DB2 uses a neural network to answer that in milliseconds. It's incredibly powerful stuff. Now that you know what it is and where it came from, let's talk about the people who keep it running. If you're looking for a career in this space, there are 3 primary roles you should know about: the system programmer, or Sysprog, the database administrator, or DBA, and the application developer. Let's start with the system programmer, or Sysprog. This is a role unique to the mainframe. In the distributed world, a DBA might install the software. On the mainframe, the Sysprog does it. They're responsible for the health of the subsystem itself. They use tools like SMPE to install the software code. They manage the system parameters, known as zparms, which control global settings like how much memory can the entire system use, or how many logs should we keep. A Sysprog is like the mechanic who maintains the engine of the train. They don't care much about the passengers, the data. They care that the train is moving. Next, we have the database administrator, or DBA. In the mainframe world, we often split this into system DBAs and application DBAs. The DBA cares about the data. They design the physical database, creating the table spaces and indexes. They're the ones running the runstats command we talked about in the performance tuning video. They handle backup and recovery. If a developer writes a bad query that eats up all the CPU, the DBA is the one who gets the alert and has to fix it. They're the conductors of the train, ensuring everything runs on schedule. Finally, we have the application developer. On ZOS, developers often work in languages like COBOL or PL1, embedding their SQL directly into these programs. This is known as Static SQL. It's different from the dynamic SQL used in Java or Python. With Static SQL, the access path to the data is calculated once and bound into a plan. This makes it incredibly fast and stable. A developer's job is to write the logic that solves a business problem, using DB2 to store and retrieve the answers. To really cement these concepts, I want to walk you through a real-world example. Let's look at Black Friday, the busiest day of the year. Imagine a major bank that issues credit cards. On Black Friday, millions of people are swiping their cards every second. This is a high concurrency environment. If this bank were running on a standard server, the sheer volume of requests might crash the system. But on DB2 for ZOS, they use a feature called data sharing. This is where multiple mainframes act as one single supercomputer. They all access the same data on the disk. There's a specialized piece of hardware called the coupling facility that coordinates the locking between these machines. So when you swipe your card in New York, the request hits mainframe A. At the exact same microsecond, your spouse swipes a card on the same account in Los Angeles, and that request hits mainframe B. The coupling facility ensures that these two transactions don't conflict, maintaining those ACID properties we discussed in the last video. Because of DB2 for ZOS, that transaction is approved in under 200 milliseconds. The bank doesn't lose data, the system doesn't crash, and the line at the checkout keeps moving. That's the power of the platform. It handles the spikes that would break anything else. So, to summarize what we've covered today, we defined DB2 for ZOS not just as a database, but as a critical subsystem of the mainframe, optimized for systems of record. We compared the DB2 family, understanding that ZOS is the heavy hauler, LUW is the agile racer, and DB2 for I is the automated appliance. We walked through the evolution from the simple relational tables of version 1 to the AI-driven insights of version 13 and the modern continuous delivery model. We looked at the career paths, the Sysprog who builds the environment, the DBA who tunes and protects the data, and the developer who builds the business logic. And finally, we saw how features like data sharing allow DB2 to handle the massive load of a global event like Black Friday without breaking a sweat. The world of the mainframe is deep and fascinating. It is a technology that runs the world, often quietly in the background. If you choose to specialize in DB2 for ZOS, you are choosing a career path that offers stability, high value, and the chance to work on the most critical systems on the planet. In our next video, we are going to get practical. We will look at the primary interface for DB2 on the mainframe, a tool called SPUFI, and learn how to run our very first SQL commands on a ZOS screen. You won't want to miss that. Thank you so much for watching. If you found this introduction helpful, please hit that like button and subscribe to the Topic Trick channel. We are building a community of learners here, and we want you to be a part of it. Until next time, keep learning and happy coding.